Hello Physical Science, welcome back. This is Mr. B, and we're going to continue on section 2 today with the modern periodic table. In our video from last night, we kind of got introduced to the idea of a period versus a group and what to expect to see on each on each little tile, if you would, for each element of the periodic table, how we're going to have its atomic number, its element symbol, its name, and its atomic mass. Talked about where atomic mass actually came from, how it's a weighted average. So now we're going to get even more in depth of how things are classified on our periodic table. So the first questions we're going to look at is what categories are used to classify elements on the periodic table. And we're going to see that elements can either be classified as a metal, a non-metal, or a metalloid. So I would definitely write those three things down. But those are the three kind of most general categorization of elements on our periodic table as elements, non-metals, and metalloids. And within the periodic table, we can kind of distinguish the differences between properties of elements kind of really quickly and simply in a way you might not have even noticed before. And how this is done is that kind of based off of just different colors. So by the state of matter at room temperature, so if you're a solid, then your elemental symbol is written in black. If you're a liquid, it's purple, or if you're a gas, you're red. And what I mean by that is if we look here at our periodic table, look right here, hydrogen has a red chemical symbol, so that means it is a gas at room temperature. And we see all these black symbols right here, meaning that all of these are going to be solid at room temperature. And we have a couple right here, mercury and bromine, which are going to be liquids at room temperature. And we have all over here, we have these are all gases at room temperature. So the color of the elemental symbol actually can kind of tell us what state of matter it is going to be when it is at room temperature. So that might be something you've never noticed before, but it's something that's pretty interesting. And and you might have noticed that some of those symbols were white. So those are elements that do not occur naturally, which those are white. So those are meaning that those are generated in a laboratory somewhere. So I think we'll go, if you didn't see it the first time, so look, we have a bunch of white ones right here. And they all have weird names because they're named after people, and it's kind of hard to read them on this one, but we'll get into that later on. But if it's a white symbol, that means it does not occur naturally in nature. Red is the gas, black is going to be solid, and then the purple is going to be a liquid. And then you'll also notice that we have different colored backgrounds. We have orange, we have green, and we have blue. So those are all stained for different things, and that's where it comes to our metal, a non-metal, and metalloid. So metals are going to have a blue background. Non-metal, I'm sorry, they called that a yellow background. I'm sorry, not an orange. So non-metals have a yellow background, and a metalloid is going to have a green background. So the colors, and you might just think maybe someone did this to just look pretty, but it actually has a definite reason of why they have the certain colors that they do. So our first class that we have are metals, and these are what the majority of the elements on the periodic table are classified as. And they're elements, so I would definitely write this down about metals, that they are elements that are good conductors of electric current and heat. So if you remember from our physical properties way back when, we held a copper wire and we could feel the heat on one end when we held the lighter up to the other. And except for mercury, all these metals are going to be solids at room temperature, and most metals are malleable. And if you remember from malleable, means we could hammer it out into thin sheets because we had that lead that we hammered out. Again, we didn't break, it just kept getting flatter and flatter and flatter. And then a new term is many metals are ductile, that is, they can be drawn into thin wires. So these are the categories, or the properties of a majority of the elements on our periodic table. And again, notice how we say most and many. There's always going to be a few exceptions to the rules here. And kind of just some examples here of different characteristics and properties of metals. When magnesium reacts with oxygen, a dull layer forms on its surface. The layer can be removed to reveal magnesium's shiny surface. So right here, letter A, if you see magnesium, it's probably going to look like this, and that's only because it has reacted with the oxygen that's in the air. And if we remove this black coating here, we're going to actually see what magnesium really looks like. It has a nice silvery shiny surface. And many telescope mirrors are coated with a metal known as aluminum, which hopefully you've heard of that before, to produce a surface that reflects light extremely well. So those are just a couple, again, properties of metals, maybe a couple uses of metals. And the metals in groups 3 through 12, and remember groups are going to be our up and down columns, are what we call transition metals. And these are elements that form a bridge between the metals on the left and right sides of the table. So again, that's kind of a good name for it. Transition kind of eases us in between the left and right side of the table. And transition elements such as copper and silver were among the first elements discovered. And one property of many transition metals is their ability to form compounds with distinctive colors. So when you combine them with other elements, we're going to form different colors, and it's pretty cool. And one example, and again, this is probably one of my favorite pictures that your book has ever given us, is that a compound of oxygen. So when you mix oxygen with a transition element known as erbium, I'm pretty sure is how you pronounce that, erbium plus oxygen is used to tint the pink glass lenses. So the reason why this dog's glass lenses are pink is because there's a compound of oxygen and erbium, and that gave that distinctive pink color, which is pretty cool. So that's one of the main distinguishing features of the transition metals, is that they are used to make distinctive colors in our everyday life. And so for our last class, the nonmetals, they generally have properties that are going to be opposite to those of metals, which hopefully we can maybe put 2 and 2 together and figure out that a nonmetal is going to pretty much be the opposite of a metal. So nonmetals are elements that are poor conductors of heat and electric current, which again, we just said that metals are a good conductor of heat and electric current. And nonmetals have low boiling points. And many of those nonmetals are going to be gases at room temperature. So really quickly, if we go back to our periodic table, remember gas at room temperature is red, and this, they called it yellow, but this orangish background, it means it's a nonmetal. And look at how many of these are actually gas at room temperature. Again, there's a couple that aren't. Again, there's always a couple exceptions to the rules, but a majority of the nonmetals are going to be gases at room temperature. And nonmetals that are solid at room temperature tend to be brittle, so that means if you hit them with a hammer, they will shatter or crumble. So remember, brittle is the opposite of malleable. And I took that ice cube and hit that, and that definitely was not malleable, it shattered. And one example of our nonmetals is one called fluorine, and it's one of the most reactive nonmetals, meaning it combines with other elements quite readily. And the gases in group 18 are the least reactive elements in the table. So some toothpastes use a compound of the nonmetal fluorine and the metal sodium to help prevent tooth decay. So again, just some real-life uses and kind of these elements, kind of how their properties show what they do in relative location to where they're at on the periodic table. So to finish this video off, okay, sorry, we're going to skip one. So our last one is metalloids. So metalloid elements are located on the periodic table between the metals and the nonmetals, and the metalloids are elements with properties that fall between those of metals and nonmetals, which hopefully you can maybe kind of put 2 and 2 together there. Figure a metalloid is kind of like a metal, but not quite. So for example, a metalloid's ability to conduct electric current varies with temperature. So silicon and germanium are good insulators at low temperatures, but when you kind of flip the script and you put them at high temperatures, they become good conductors. So that's kind of an interesting example. We said metals are always good conductors. We said that nonmetals are poor conductors, and silicon and germanium, depending on what temperature they're at some temperature they're a good conductor, and at some temperatures they're a bad conductor. And so I think that's a pretty good example to show us that metalloids are kind of right between metals and nonmetals. And so to finish it off, we're going to look at how properties vary across a period, and remember period is our rows in the periodic table. And across a period, from left to right, the elements become less metallic and more non-metallic in their properties. So that's kind of common sense there. If you're going to become less metallic, therefore you're going to become more like a nonmetal. And so from left to right, period 3, so period 3 is going to be in our example. There are 3 metals, sodium, magnesium, aluminum. There's 1 metalloid that's silicon, and there's 4 nonmetals, phosphorus, sulfur, chlorine, and argon. And we're going to take a look at how their properties are very different than one another. So sodium is going to react violently with water, so water is going to be our example here. Magnesium, however, will not react with water unless the water is very hot. Aluminum does not react with water, but it does react with oxygen by itself. Silicone is generally unreactive. Phosphorus and sulfur do not react with water, but they do react with oxygen. Chlorine is highly reactive, and argon hardly reacts at all. So that shows us that these characteristics vary, and don't worry about writing these down too much. We will talk about more of that in class. So that's it for section 2. Let me know if you have any questions.